computer. Done. Okay. Uh, Welcome, Professor. We are thrilled to have you at our university. I will deliver some welcoming remarks and then I'll hand it over to you. You'll have 40 minutes for your lecture, followed by 20 minutes for Q&A. Um, the University of Chihuahua, through the Faculty of Engineering, is honored to continue this cycle of conferences of the National Network of Water Postgraduate Programs. This is an initiative by the university to invite national and international researchers who study water-related issues to engage with our postgraduate students. Today, we continue with this cycle of conferences with a presentation by Dr. Sharon Megdal. Dr. Megdal needs no introduction. She holds a PhD degree in economics from Princeton University. She is director of the University of Arizona Water Resources Research Center. Um, Dr. Megdal research focuses on hydrogeology of arid basins, stream aquifer interactions, hydrodiplomacy, and hydrology of urban areas. She has published numerous scientific articles, led projects, and taught various courses related to surface and groundwater. Today, she will deliver the lecture entitled Identifying Solutions to Water Resource Challenges under Drying Climate Conditions. The floor is yours, Professor. Welcome to our university.
Well, thank you for having me, and it's my pleasure to be here. And I'm going to get rid of these little, I had your camera on, and now all I'm seeing is my slides. So I don't see any of the audience. And when I'm done, I hope we can go to gallery mode so I can see the people who are in attendance. But thank you so much for the invitation. What I'm going to do is talk some about the Water Resources Research Center, about our work, about some of my work. And if I start running out of time, I'm setting my 40 minutes here on a timer. I'll go through some things pretty quickly, but throughout the presentation, I have QR codes, I have links to articles that are have screenshots, because I like when my presentations are useful to the audience to go back to. If they want to pull some things up, they can. And so you're welcome to distribute this as a PDF afterwards. Just don't make it too small size a PDF, because then some of the QR codes don't work. So you'll see a lot of screenshots, and these photos on the cover slide will show up a little bit later, so I'm not going to say anything about them here and now. So the Arizona Water Resources Research Center that I direct, we're a relatively small center. We're part of Arizona Cooperative Extension and the College of Agriculture and Life and Environmental Sciences. And we pride ourselves in bridging the academic and the real world of water management. And I've been director, actually July 1, I'm celebrating, hard to believe, my 20th anniversary as director. And our goal is to help inform people about what's going on out there in terms of water resources, through our applied research, through our educational program and our engagement programs. And we have a lot of programs. I think, Miguel, you've been an attendee at several of our webinars. We have an annual conference and publications. And I invite any and all of you to subscribe to our weekly wave. It comes out every other week during the summer. We call it the Summer Wave. But it includes notice of our presentations, our programs, news articles, our publications, and the like. So please do connect with us. And I do want to highlight our signature event is our annual conference. It's not always the same time of the year. For a couple of years, due to COVID and other considerations, we were offering it in the summer. This year, we went back to March during the academic year. And our last topic was implementing water solutions through partnerships. It's meant to be an issue-based type of conference, not so much an academic conference. We do have academic people speaking, but it's not like your technical type of conferences where you have to be specialized in a certain field to attend. And for the last several years, we've been offering non-interactive participation for free via Zoom. We also record all of the sessions and post them, except in the rare instance that we don't have permission. We were honored this last conference to have our governor, as you can see seated next to me in the lower right, Governor Katie Hobbs, as a keynote speaker. And after her remarks, we did some Q&A, and it was quite an honor to have her speaking about her priorities in terms of water resources, and particularly some groundwater issues, which I will mention in a few minutes. I write, in addition to my academic type publications, I write reflections essays, about 1,000 words or so. And this is the last one, the most recent one that I wrote on my way to the World Water Forum, which was held last week in Bali. And I got some allergies while I was there, so I'm sounding a little stuffy because of that, but otherwise it was a great conference, about 15,000 people there. It from Mexico, the main attendee was actually Commissioner Resendez of the International Boundary and Water Commission. I got to see her briefly. There was just so much going on, but some of the students may like to read this. It's all about networking, which I've really been focusing on quite a lot. And again, I'm providing the QR code to to the page with all of that, all of the reflections. So I do teach a class because I'm an administrator and because I do engagement outreach work and research. I actually only teach one class a year. I teach it in the spring semester. It's a graduate class in water policy. It's called Water Policy in Arizona and Semi-Arid Regions. And this is a slide I use in the first meeting of the class because I focus on water policy and management. I connect with hydrologists and engineers, but I myself am not a hydrologist or engineer. I'm an economist by training. And my work itself is very applied, looking at what's happening out there kind of on the ground, on the waterscape, in terms of what are some of the practices, what are some of the challenges, what are some of the opportunities to address those challenges and the trade-offs associated with those possible solutions. And there are a lot of things that affect what we see going on out there, and I've underlined a few. Clearly, the legal framework is very important. How decisions are made, who's making decisions, is it very centralized, is it decentralized? I'll come back to that issue a little bit later in the presentation. But you can see, of course, there's many issues: where the water is, the economics, the politics and public values, the status of technology and what options are available, etc. And the context is, of course, extremely important. And of course, for all of you, you're familiar with the water cycle context. Sometimes we have to remind people no new water is created. But I'll go to the next slide, which shows maps. I like to include maps when I make presentations. I like to advise students and others to include maps in their presentations because not everybody knows where people are. When I was in Bali at the World Water Forum last week, and I showed a slide similar to this about the Colorado River Basin, where Arizona is located, I asked the audience, it wasn't a huge, maybe 40 people or so, maybe a few more. Do you know where Arizona is? And, very few people do know that. They may kind of have a sense of where the United States is. They may not know that we share a border with Mexico, also one with Canada, etc. So I like to use maps, and because we are located in the Colorado River Basin, and in a slide in just a moment, I'll show you, we do depend on the Colorado River water for quite a bit of our water supplies in the state. The importance of this map on your left is it shows the hydrologic boundaries of the basin. It's a large basin, about 40 million people in the two countries of the United States and Mexico rely on the water for to different degrees and for different purposes, possibly. 7 states in the US, 2 states in Mexico. But also what's very important is water gets transported outside the boundaries of the basin. So it goes to Los Angeles. There's a map. This map is not the US Bureau of Reclamation map. This is a map produced by a water center up at Utah State University. And what's special about this map is that it also shows how Mexico diverts the water from where it's delivered from the US into Mexico to the west. And it provides water to some of the agricultural lands to the west of the Colorado River. And so there are many people outside of the hydrologic boundaries that are depending upon the river water through transport. We in central Arizona are dependent on Colorado River water that's delivered through a constructed canal called the Central Arizona Project. And I was not planning to talk too much about some of the details of the water deliveries and the like, but realizing that you do not live in the Colorado River Basin and you may not be following it that closely, is pursuant to the 1944 treaty between the two countries. It is the obligation of the United States to deliver water to Mexico, whereas in the Rio Grande, the direction of delivery obligations is the reverse. And so the Colorado River flows from north to south into Mexico, and by treaty, the US has the obligation to deliver, and excuse me, I haven't made all the conversions to million cubic meters, but delivering 1.5 million acre feet of water to Mexico, unless that's been adjusted because of shortages on the river, which it has been in the last few years. This map on the right shows those physical boundaries, again, the hydrologic boundaries outlined, but looking at it from the perspective of some of the indigenous nations. There are 30 native nations or indigenous nations in the Colorado River Basin, and some of them span multiple states, and they have a different perspective when looking at water supplies than the states may have. But yet we're all working on this together through a system that largely is dependent on state interactions in the United States and then nation to nation interactions between the United States and Mexico. Now, another context framework I like to talk about is the context of wicked water problems. I think this context of helping people realize that we're dealing with some big problems that don't have a single solution to them. And the problems themselves, and I'll talk about a few in just a moment, are related to other things besides just the water situation. And so these are big problems. They don't have a simple solution or pathway to resolving them. And collaboration and interdisciplinary work are necessary for addressing them. And I underline, for the purposes of this talk, interdisciplinary work, because I realize I'm speaking to mostly hydrologists or engineers, not necessarily all. I think I saw Ishmael come in, Aguilar. Nice to figuratively see you. But it takes all hands on deck to address these issues. And I also underscore the importance of process for identifying these solution pathways, and I'll come back to that a little bit later in the presentation as well. All right, so now I'll talk a little bit about some of the wicked problems. It, for the Colorado River, we have a tremendous imbalance between supply and demand. We had an imbalance even before approximately the year 2000, since which time we've had low flow conditions due to, you might call it long-term drought. Some are calling it aridification. The climate is changing. And even before that, back in around 2000 in the late 80s, early 90s, this is a photo taken from Hoover Dam on the left. And these spillways, the water was pretty much up to the top of the spillways in the 89 to 93 period of time. And then even again, as recently as about 2000. But since the early 2000s, 2002 and beyond, the storage behind the dam has been diminished. We've been relying on water in storage because the river's been over allocated. Aside from the fact that the flows are being reduced due to climate change, the river was over allocated. When the river wasn't producing as much as it had, people started drawing on the savings account of the storage. And so here's the dam on the right, here down here. And this whole area, if there was a full storage reservoir, you wouldn't be seeing all these brown pieces of land. You'd see some of the high pieces, but you'd see much more water than you do. This was taken in December 2022, when the reservoir, which is the largest storage reservoir when full in the United States, in December 2022 was probably about 27, 28% full. It's a little bit more full now because of the good winter we had, the winter 22 to 23, but it still doesn't look much different than it does here on the left-hand side. My sister and her husband, who live in the East Coast of the United States, were just visiting, and they took some pictures from the dam, and you can't tell very much difference of a few feet in elevation at the spillway here on the left. So this supply-demand imbalance is significant, and this is a telling graphic that the U.S. Bureau of Reclamation put out, where they basically looked at what average flow conditions looked to be from 1906 to 1999, 15.2 million acre feet. If you look at the 20-plus year period, 2000 to 2022, you can see the drop. I mean, this is a discernible difference. And if you look at even a shorter period of time, from 2018 to 2022, it's even lower. And so we've had, as I said, a river that was over allocated to begin with, particularly when looking at the states of California, Arizona, and Nevada, and the flows are lower. And so this is a big problem to deal with. And agriculture is the biggest user of water in the United States and in Mexico as well. And just to give you a little snapshot of what things look like in the state of Arizona, just looking at who's using the water and where does the water come from, you can see that agriculture uses almost 3/4 of the water in the state of Arizona. Municipal use is about 1/4, a little less, and then industry, which includes electricity and mining. There's quite a bit of mining that goes on, and certain other things. And the whole question of agricultural use of water is big, because if we have less water to use and we have a growing population, hopefully a population that's looking to increase protein and food intake, there's a lot of challenges within this agricultural sector itself. And I show a screenshot here. The president of the University of Arizona formed a commission to look at the future of agriculture and food production in a drying climate. I served on that. And we put out a very non-technical report. We put it out in a short period of time. People from various backgrounds were on the not very large commission. And if anybody's interested in that, I have provided the link to it. And then if you look at where the water comes from, more than a third comes from the Colorado River. So Arizona as a state is quite dependent on this river that has less water flowing in it in the last 20 plus years. We have some in-state rivers. We rely on groundwater quite a lot, and recycled or reclaimed water, which is an important source going forward. And so because of that dependence on the Colorado River, we're very concerned about its status and how it's divided up among the users. And then we're also concerned about the status of groundwater in our state. And groundwater depletion, I identify as a second wicked water problem. Groundwater is invisible, so it's harder to know how much you have and what's happening to it. This cross section here comes from a model from the Arizona Department of Water Resources, the state agency that's responsible for modeling groundwater and looking at groundwater regulations and implementing them. And basically, what they said back in 2018 or so when this model came out is that, we're relying on fossil groundwater. It's being depleted. We've known that for a long time, faster than nature replenishes it. And if you look at the projected growth for the area and the continuation of some of the farming, which has had its surface water curtailed because of the shortages on the Colorado River water, we have some big issues there. This is an area, if any of you are familiar with Arizona, this Pinal active management area is an area between the Phoenix metropolitan area and then the Tucson metropolitan area to the south. I live in Tucson. That's where the University of Arizona is. And then about a year ago, almost exactly, it was June 1st of 2023, an updated model came out for the Phoenix area. And there were articles in the Washington Post, the New York Times, plus all the local papers that said, while it's not as bad as this agricultural area, we're still running the risk of not having physical groundwater supplies to supply the needs of communities for the 100 years that our regulations say you have to show you have sufficient water. And so it's because of the concerns about relying on groundwater and what's happening in the areas of the state where groundwater is managed, as well as areas of the state where groundwater is not managed, that our governor, Katie Hobbs, established a Governor's Water Policy Council. We started meeting almost exactly a year ago. I think the first meeting was May 27th of 2023. And we were asked to come up with some recommendations. I serve on that, and I served on the Rural Groundwater Committee, and we did come up with recommendations in this report that was issued in January 2024. So again, don't have time to get into depth on these things, so I'm providing you links and sources if any of you want to look further into these matters. Another wicked problem is the lack of access to water and sanitation. The UN Sustainable Development Goal number 6 has been access to clean water and sanitation for all. Quite aspirational, but many areas of the world, including areas in the United States, particularly the Navajo Nation, tribal community nation in Arizona, the largest actually tribal nation in the country. About 35% of the people there do not have running water to their homes. And so addressing this, it looks like a water settlement may occur with the federal government that might bring some money to this, a sizable amount of money. And this may be an example where time and money can help address it, but it's going to take a while. And then the last wicked problem I want to mention is the limited consideration given to nature's water needs. And remember that these are problems that have many reasons behind them. And often they have to do with the prioritization of water for meeting human needs and economic uses, such as agriculture and communities and so forth. And because of the way the Colorado River has been developed and the dams and the deliveries, the water has not been able to reach its natural end with reaching all the way to the Sea of Cortez of the Gulf of California. And I put here a video about the 2014 pulse flow. This is a beautiful video narrated by the American actor Robert Redford. And this is a photo of a little girl in Mexico playing in the water in what is usually a dry riverbed. But because of the pulse flow, a large amount of water was sent south from the diversion point instead of all going west. And this has been a very important learning experience and lots of good information collected by the federal governments in both countries. Universities have been working on this, a number of non-governmental organizations, NGOs. There's not been enough water to repeat that pulse flow of 2014, but there is a lot of restoration going on and some innovation in obtaining the water to do some of the less flashy, I'll call it, restoration. And then this photo, which I had on as one of the two cover photos for my presentation, this is taken of the Santa Cruz River just north of the border with Mexico in Arizona. And what's supporting this really lovely growth here is effluent from the Nogales International Wastewater Treatment Plant, more than 2/3 of which comes from Mexico. This is a plant that's operated by the International Boundary and Water Commission. And we have a beautiful lush area, but much of the Santa Cruz River, as it travels north from Mexico into Arizona, it actually starts in the state of Arizona, flows down into Sonora, then back up from Sonora into Arizona, goes through Tucson, and the only places where you see water on a regular basis is where there are effluent discharges from wastewater treatment plants. And so the environments had suffered over the years because of increased pumping and diversion of water supplies. So we have problems, but we really do need to focus on the solutions. That's really what it's all about. And so here are some of the categories of solution options to address the imbalance of supply and demand. And this is an article that I was asked to write, invited to write for a policy journal, a natural resources journal, because it was recognized that Arizona, because of the low priority of water delivered through the Central Arizona Project, is highly impacted by the cutbacks in deliveries of Colorado River water due to the shortages there. And so as you see on this list, conservation, of course, conservation, but it's not enough. Greater efficiency, particularly in the agricultural sector. If you change from flood irrigation to pressurized spray or drip, that doesn't always translate into less water use. It may sometimes even translate into more water use as agriculture plants more crops and uses that saved water. Reuse, I've underlined here, managed aquifer recharge. That's a mechanism that I'll say a little bit more about, used across the globe. And here, moving water, desalination, marketing water, rainwater, stormwater capture, and how we design our buildings, communities, and landscapes. These are all solution opportunities and what might be implemented at any one place or in any time period will depend upon a lot of factors. Again, this I've just put in here if some of you are interested. I know there's often a lot of interest in managed aquifer recharge, in deliberately storing water in aquifers for use either shortly thereafter, almost at the same time, or maybe for the future. And so there are some interesting case studies in both of these volumes. One is a UNESCO volume, and the other is a special issue of a journal produced after one of the international symposia on managed aquifer recharge, which is held every 3 years. And you may all be aware, recharge is the process of adding water to an aquifer. Of course, it happens naturally. It can happen incidentally. Agriculture uses water. Not all of it is used consumptively by the crops. Some of it seeps into the ground. It might seep into aquifers or collect as tailwater. That's considered incidental recharge. But we've made a lot of use of in central Arizona, particularly in the late 1990s and then into the first decade of the current century, is artificial recharge, where you deliberately add water to an aquifer. And we've hosted in Tucson, and even this upper photo shows a field trip of my class from before the pandemic, but I've had guests from the state of Sonora, water professionals, join my class field trip or otherwise visit some of these recharge projects that some of them are quite large and are ways to store the water when it's available for later use. But in Tucson, we're actually storing it, having it mixed with ambient groundwater to avoid the costs and some of the issues that arose from a surface water treatment plant. So this has been a very important mechanism for us in Central Arizona. I've written a number of articles about it. And this just is a graphic. This is quite old, this graphic, but I like it because it shows how Tucson was storing in these surface water basins, having the water recharge, mix with the ambient groundwater, and then through recovery wells, recover a blend of the stored surface water mixed with the in situ groundwater, and has worked very well for the city of Tucson to deliver surface water in an indirect way to its customers. And this one article is not an open access article. If anybody's interested in it, you can let me know and I will share it with you. This is a short article that really just talks about some of the challenges we had when Colorado River water was first delivered to the Tucson area about 30 years ago, and it caused some real problems. And out of that, we had to develop a plan B, which is a very drought resilient approach. And so I'm just going to skip over this. These are just some pictures of how we do the recharge. The bottom one is an example of where surface water is used in place of groundwater. We call that groundwater savings. And I wrote an article a few years ago that talks about Arizona's regulatory framework, which can be instructive for those who might want to undertake aquifer storage and recovery programs. Now, interestingly, and this is another publication of ours, I'm going to go a little bit faster because of the time, but interestingly, and I'll say a bit more about it here, is that you really have to look at the underlying regulations regarding who has the control and ownership of the water. I had a PhD student from Mexico, and one of the papers for her dissertation was looking at the regulatory framework in Mexico and how artificial recharge has been utilized there. And it's a very different situation than, let's say, in Arizona, because of the centralization of ownership of the water supplies. If you put water in the ground, it then becomes owned by the federal government of Mexico. And so the ability to make later use of it would possibly not be there for you. And so you have to kind of look at the whole cycle and how these things work. So I want to say a few words about the Transboundary Aquifer Assessment Program. This is something that I've been working on for actually about 15 years now. We've been working in the state of Arizona with our Sonoran colleagues and also with our federal partners, both from the US and Mexico, on 2 aquifers here. We have a lot of things posted on this if people want to take a look at this. But this is an example of where right at the start of this is an article, I think it's from 2011 or 12, 2011, as I can see from the screenshot, where, you know, as you start working together to look at harmonizing the data, trying to get on the same page on the status of groundwater, you have to understand that the water governance is very decentralized in the United States. It's centralized in Mexico. And so our federal government has very limited jurisdiction when it comes to groundwater at the groundwater period. That's more a state responsibility. And when you look at the International Boundary Water Commission, SILA, you know, on the Mexican side, they have a long history of working together, and particularly since 1944, on surface water and wastewater issues, but very limited, but very limited, working on groundwater. So when there was interest to start a program of binational assessment of groundwater, it took a few years to just come up with the cooperative framework for working together. And so it was in August of 2009 that the principal engineers for the International Boundary and Water Commission signed a 3-page cooperative framework that really has guided the work that we've done collaboratively on the aquifers, the Santa Cruz and San Pedro aquifers shared by the states of Arizona and Sonora. And I list here the basic 6 principles that are quite robust. And in fact, I read these principles in one of the presentations I made at the World Water Forum last week, because this is a very, in my opinion, elegant document. It's simple, but it really makes sure that the countries preserve their authorities and but at the same time work together to try to get on the same page as far as groundwater and aquifer conditions. And at the bottom, that's a paper that was part of a dissertation of another student from Mexico, Elia Tapia, about how this is a model for transborder groundwater cooperation and collaboration. And again, I'm happy to have this provided to you so that you can read this and read any of these items at your leisure. We put together a bilingual, binational report, the first of its kind, back in 2016 on the San Pedro Aquifer. Fully bilingual, all of the legends, everything in English and in Spanish. We put together a 6-page bulletin that I show here on the right. And what I've circled here is the logos, because this itself was notable that you had 2 universities, the University of Arizona, University of Sonora, 2 federal agencies, CONAGUA and the U.S. Geological Survey, and then the International Boundary and Water Commission as the coordinating, facilitating organization. And here's just a screenshot of the the bulletin and how the harmonization here on the lower right of the maps worked. And we've been documenting the science and cooperation across the regions and disciplines. This article that I have a screenshot of in the Journal of Hydrology Regional Studies from 2018 talks about working across different disciplines and cooperating, working across different languages, different cultures, and the like. And then on the right, this is the editorial paper for a special issue of the title shown here, Advances in Transboundary Aquifer Assessment, that I guess edited with someone from the US Geological Survey. And there are several papers, not all from the Transboundary Aquifer Assessment Program, but most of them are in fact by authors who are working at the shared border of the two countries, including a paper from University of Texas El Paso researchers who are not officially part of the TAP. And then again, here's just some graphics, some screenshots of some particular papers. Another paper from Elliot Tapia's dissertation that was published in the Journal of the American Water Resources Association. It is open access, but it goes to the point, and this is kind of like the common thread of the story, whether it's the Colorado River, whether it's looking at precipitation events and recharge from them, the water balance and the groundwater conditions is not going in the good direction. It's going downward. And this paper talks about that, particularly looking at some of the downstream flows of the effluent coming out of that Nogales International Treatment Plant. Here's a paper from the special issue of just looking at the a review of climate change impacts along the transboundary Santa Cruz River Basin. And here it says, this urgent risk for water shortages calls for proactive and collaborative binational planning to achieve a sustainable transboundary aquifer system. But the program, the Transboundary Aquifer Assessment Program, and both Elliot Tapia and Elon Shamir work as consultants to my water center on the on our work on the Transboundary Aquifer Assessment Program. But separate from that, a few of us formed an informal working group to say, well, what about connecting the science to the policy, and particularly the policy of groundwater management? What might it take to get there? And so we put together a paper that we presented at a groundwater summit in December 2022 about connecting science to policy. And then we just put out a paper earlier this year about how you might craft binational groundwater agreements for binational groundwater management. This is not sanctioned by any official agencies or so forth. What we're trying to do is get some discussion going about how you might see binational groundwater management take shape. So in conclusion, I'm down, to my last couple of slides here. I mentioned earlier that process is extremely important. I've written, it's not published yet, a case study for a handbook on water diplomacy, and the paper's title, Factors That Contribute to Successful Diplomatic Outcomes, case study of the Colorado River Basin Cross-Boundary Institution. This is in a kind of a global international volume, and the case study really is about the International Boundary and Water Commission. Those 7 factors I list here are the ones I talk about in the paper. Transparency is, of course, important. And then the sharing lessons learned, not only the positive lessons, but also the negative lessons are very important to processes of identifying solutions and implementing them. This is just a collage I put together of my 6 different panels I was on last week. And so many of them relate to things I've talked about here. people all across the world are dealing with similar challenges, and there's great interest in sharing insights and lessons learned. And so in conclusion, I just want to say we know the problems, we need to focus on the solutions, there's lots of work to be done, collaboration and partnerships are essential, and we need everyone to be informed and involved. And so with that, I'm going to stop sharing my screen. I went a little bit over the 40 minutes, but I hope that's okay, Miguel.
Excellent. Well, we still have a little bit of time. If someone wants to speak, if someone wants to ask some topic related to the team, feel free to do it. Si alguien quiere hacer alguna pregunta, si alguien quiere hacer algún comentario, lo pueden hacer. We have some messages from students. Congratulations for the webinar. This was very interesting. I really like your phrase. We have problems, but we have to focus more on the solutions. We also have some questions that students have sent through the chat. How do you imagine how water supply in arid zones will be like in 50 years?
Ooh, that's a good question. That's a tough question. I would not expect them to be better than they are now. And certainly if we do not figure out what to do about groundwater and the depletion of groundwater, they could be far worse. And that's why trying to raise the attention given to groundwater is really important. And one of the things some of us were talking about last week at the World Water Forum, some of us have been talking to each other for a long time. And in the groundwater scene, very often the interbasin discussions are about surface water, and groundwater is an afterthought. And what we were talking about was that we have to stop talking to each other, but talk to everybody for people to understand that there are communities that are 100% dependent on groundwater, many of them along our shared border. And so, you know, we can't overlook that, but it's going to be hard to come up with a binational agreement on managing groundwater. It's hard enough to come up in our state of Arizona with agreement of how to manage groundwater in rural areas, you know, even within one state, within one, you know, kind of culture. And so this is really hard work. And that's why a lot of times, just yesterday, I gave a talk to a group of individuals, very informed individuals, including my predecessor, director of the Water Center, at a retirement community in Tucson, because we really do need to have everybody informed. And so, you know, if we all work together, hopefully we can avoid having a bad future. But if we don't pay attention, the future could be worse, far worse than what we're dealing with now.
Alfredo Granados, do you want to say something?
Yes, thank you, Sharon, for such a nice presentation. I did posted the question on the chat, but I would like to ask you, can you give us an estimate on the future for TAP on both sides of on the border? How do you expect this is going to be moving forward in benefit of the share and common interest for the transboundary aquifers? Thank you.
Yes, thank you. Nice to see you, Alfredo. What the TAP itself may look like, if that's your question, we have to see. One of the articles that I showed was about the asymmetry of governance and institutions. But another big challenge has been what I'll call the asymmetry of budgeting and resources being available. I've been part of this program since its inception, and there have been times where Mexico had funding available, Canagua had funding available, and we on the US side did not. And lately, the US side has had some funding. I know you're well aware of this. I know you work with the New Mexico Water Resources Research Institute. We don't have a lot of funding, but there's been no funding for the Mexican side. So what we're doing is working together. I'm very pleased to say that we're working together to see how we can come up with some binational work plan priorities. And so there's active effort right now for the parties to collaborate on a water atlas. And we had a meeting very recently of the Arizona Sonora partners. We've been working collaboratively for a long time, and we were talking about having a workshop. I'd like to have more engagement, more outreach, more talk about it, but what we realize is we need to have an expert workshop because we're not ready to talk outward because we're not necessarily on the same page. I feel somewhat optimistic by what's happening in that part of my role is, so I'm not a hydrologist. I don't do the modeling. I do a lot of talking, but I also do a lot of the diplomacy aspect of this. I go back to our Congress and I testify about extending and having more funding. And I think that if we could show how well we're working together and will work together and how that benefits the communities, I think there could be good support for it going forward. But we have to be very active, proactive in doing that. And there are a whole lot of other problems that people are worried about right now. So it's competition for limited resources, not just money, but time, people's time. So I don't know if that quite answers your question, but I hope it at least partly did.
Yeah, I completely did. Thank you, Sharon.
Another just give me a minute. Another comment here. It says, thanks for sharing the books. It was pretty nice to know how researchers are working in order to improve the knowledge about water. We have another question. This is a good one. Greetings. Excellent and important presentation. In the formulation of policies and regulations, how can we overcome particular political interests and achieve water management for the common good based on science, equity, and development?
That is a good question. That's a tough question. You know, something that was said last week quite a bit in different presentations was having the political will to do certain things. Sometimes, though, I think it's too easy to just say, well, you got to have the political will and, you know, to get things done. And it's maybe a little hard for me to articulate this, but I had on that early slide about the things influencing water policy and management. And one is public values and political values. And elected officials, decision makers, they're supposed to reflect what their voters, what their residents, what their constituents want done. And so something I like to say about water is that we talk about a lot the word water stakeholders, right? I don't even know, maybe Miguel, afterwards you can tell me what the word is, write it, you know, in an email, so I'll have it, or in the chat, what the Spanish word is for stakeholder, right? Because that word is used a lot. And at one of the sessions I was at last week, it was about how involvement of civil society can address crises. And there were purposes of those. My presentation was all about what do these words mean that we're talking about. And when it comes to stakeholders, sometimes the debates are among the expert stakeholders. They are the agency people. They may be the big users. They may be some of the powerful users. But everybody is a water user and everybody is a water stakeholder. And those above a certain age, at least, and the age seems to be going down as the youth are rightly saying, we are very concerned about these things. We're all decision maker influencers. So it really does take all of us. I really mean it very seriously when I say it's all of us have to be part of this. And I think it's going to take time for people to, let's say, if they want to change, to achieve that change, so that there is political will to do some things differently. But it's hard. It's very hard. So I'm just looking to see if Ishmael, he's maybe gone, but maybe by show of hands, because you all have your cameras off except Miguel, but Professor, how many of you have taken courses in economics, a course or more than a course? Just do a raise hand on your Zoom.
Si alguien no entendió
Yeah, I don't
la
see Alfredo. But the reason I'm asking for that is that this isn't meant to be kind of a cop-out, but so I studied economics, and I didn't study water economics. I studied economics of taxation and government expenditures, and I kind of became a water professional in an unexpected way. That's a story for another day. We don't have that time for that here. But the economic framework is that if you want to improve things, and you can improve things, it helps if there's a way to compensate those who might be adversely affected. And we're in a situation where if you change the status quo, there tends to be losers, and people don't want to lose their position. And we don't have mechanisms for those who gain to compensate the losers. And it just makes it very difficult to change paradigms, change regimes. But that doesn't mean we don't try. Even working on, like I showed at the very end, questions of, can you get to binational management of groundwater? There are concerns about doing that. I mean, there are concerns about it would be viewed very negatively by certain, high-powered political people. But again, if we're concerned about our communities in the long run, in that 50 years, like the question was, and these communities are dependent on groundwater, we have to keep working on it. And one of the things on my list of process was combine persistence and patience. Sometimes you have to be persistent, but you also have to be patient because things don't change very often overnight. So I don't know, that's just maybe more philosophy than an answer, but that's the best I can do this morning.
Okay, well, thanks to Sharon for her great contribution to the state of art of water resources with a binational perspective. It was really interesting, excellent presentation. Well, we are out of time. I want to thank Dr. Megdal, who, despite having allergies, is here
I
sharing
made
her.
it through. I didn't even start coughing, so I'm good. I'm feeling good.
He made it. He made to share her knowledge, and with this we will finish this webinar. Professor Megdal, thanks again. It has been a privilege to have you here. I will send you your recognition certificate by email. And with this, we conclude this conference. We
Well,
thank
thank you.
everyone.
Thank you.
We thank everyone for attending, and see you next time.
Bye-bye.
Gracias. Bye.